Welcome to Tacit Talk, episode number 30. And it is the first day of 2026. Happy New Year. And we are bringing you a hopefully familiar voice. And we haven't chatted in a while. It's Adám Brudzewsky, fellow co-host of Arraycast, which is on hiatus for the moment, but we will be back hopefully in this month. So if you're a listener of that podcast, we do plan on bringing back the episodes. But for now, I think I had you on episode number 4. I looked it up, and it was all the way back in 2024, which I was going to say was last year, but it's actually 2 years ago now, as of today. How's it going, Adam?
Yeah, it's good. I've been keeping busy. I've not been doing a lot of content creation, so it's nice to return like this.
I guess, yeah. Is Arraycast the main form of content that you do on a regular basis, or because I know you do the conference talks, and I saw the behind. I believe it's linked in the show notes. If not, it will be later, or not show notes, description for the YouTube video, but show notes if you're on the website. You did make a Dyalog 20, which is what we're here mainly to talk about, the behind operator, which is the most exciting thing, in my opinion, to happen in a while, as one of my videos pointed out. That was content that you made, but was that maybe a while back that got released later,
or? No, it's not that long time ago I made that. But remember, I used to do a whole lot more. I used to have these like weekly things that I used to record like year round every week, or so. There was a while when I was like putting 1.5 videos per week on average onto YouTube, like consistently for a year. And so there's been a lot less. I have, I think, 3 videos I made about version 20. So it's like we decided with like 5 big features that we wanted to draw attention to, even though that's a lot of stuff in version 20. And then we made 1 video for each of these features, and I made, I think, 3 of those. I might have made another one as well that then somebody else re-recorded that because we wanted to get a few different voices as well. And then I've been doing Arraycast, and then that's been a hiatus, and then there hasn't really been anything else. There wasn't a Dialog user meeting this year, and usually I have a relatively large part of that as well, both talks that are recorded and workshops, and that didn't happen this year. Instead, there was the DINA, the Dialog North America meetup, which I wasn't part of. So there hasn't been a lot of content creation there, or we should say there hasn't been a lot of visible content creation where you see my face or hear my voice. But I have been doing a lot of things. So the APL challenge, which is this constantly running introduction to APL / competition thing, that's all me now. So I've been writing all those problems and tests and the whole system, and that has been publishing my creation, right, my content, but it's not very visible.
Right. And the current one that's running right now, we can link it later because it's definitely not in the description or show notes now. That started in October, correct?
Yeah, I think that's right. No, November, I think 1st of November approximately, because it runs November, December, January, and then the next round starts in the beginning of February.
Okay, so there's still time if you have not checked it out. Even if you're an APL pro, I always do it. Sometimes I do it in multiple languages, and yes, it is a very good way to dip your toe into APL if you are APL curious. If you happen to have stumbled on this video, I mean, I have a number of subscribers. Most of them know that I like array languages, but maybe this is the first time you're hearing about array languages. APL Challenge, go check it out. So, I mean, we can start talking about the biggest news it's happened since Arraycast went on hiatus, is Dyalog 20. You said that there's 5 videos of 5 major features. I'm now wondering, is the behind operator one of those? Did it make the top 5?
Yeah, that's why there's one of those videos about it. That is considered one of the major ones.
Oh, so I wasn't sure if it was an extra video that got made as a supplementary non-top 5, but we know people like Connor are going to be excited about it. So the behind operator is one of the top 5. So before we get into that, what are the other top 4 features amongst the plethora of things that shipped with Dyalog 20?
So you can actually find out very easily. We have a completely overhauled language help system online, and it's made with material from MacDocs instead of the old system, which was an interesting thing we had. And it is very front and center. Like if you go to the introduction for the highlights there, and you can get to this through docs.dialog.com. And it says that the five release highlights, they call them, is the array notation. There is the new and improved features for namespace manipulation. And then there's the behind operator. There's a new system function called quad shell, which is a very capable interface to not just actually to the shell, but just running external programs. And then there's the inline tracing, we call it, where you can step through primitives and derived functions and so on. So those are the five, and each one of them have a video. And so that's another way you can find out. If you just search on YouTube for Dyalog APL, I think you'll find all the newest videos on those five features.
Oh yeah, I guess technically I can do this, right? I mean, because I'm screen sharing my entire screen, so I can make us disappear for a second. You won't see this, Adam, but the viewers on YouTube probably will. So this is the docs.dialog.com, going to the introduction of the release notes of V20. So the five bullet points here. I was wondering, I was like, should I share my screen? I was like, wait a second, I am sharing my screen just with YouTube, not with you. All right, so I mean, what should we? We're gonna spend. I mean, I'll throw it to you. We can talk about whatever you want to talk about. You obviously know at what we're gonna talk about at some point. We can do that right away. We can do that at the end. We'll leave it up to you where you want to, drive the tour of Dyalog 20.
So we're doing a whole tour of Dyalog 20. Well, I mean, those five videos are really great. They really do show off a lot of the capabilities. Behind operator is great. I don't know what's more great. Whether the behind operator is something I've started using a lot now that I have it available. Unfortunately, I often have to write code that has to run in previous versions as well. So, but for any new code that I write, I tend to use it, somewhat. I have this distaste for parentheses to govern the order of execution. I prefer either breaking up my my statements and giving meaningful variable names, or using composition around it. So it gets, I guess, a bit more used by me than maybe other people would. But array notation, I think, is the one that makes the biggest difference in the pleasure of doing APL. It has so many impacts that I certainly didn't realize in the past many years that I've been engaged with this. And the bind operator, you can just define it yourself. I've typed it out so many times now, and it takes a few seconds to define an operator that does the exact same thing. Array notation, you can't. That's an integral part of the language, and I've been working on getting us array notation into the language for a decade. Right? That's a long time in tech. That's a long time in a programming language development. I guess from like C++ developments that they take a long time to get into the language. But that started with when I heard a talk at the Dialog user meeting on Sicily in 2015, and then I've been busy with that on and off since then. And then finally, here it is, and I can actually use it. And even though I've been spending a decade on that, and I've been running models, and I even set up a website where I could play around with it as like a sandbox thing with instant evaluation, so I could get a feel for it. I did not realize all the ways that it could be used, and I think that it will. You could say revolutionize, but I don't want to use too big words. But I think it will open up avenues for writing APL programs in radically different ways, and I think we haven't seen the end yet either. Because there are a lot of ideas that we got as it was being implemented properly, of ways that it just fit in, that completely changed everything. It has had enormous impact on the rest of the version 20 product in ways that we did not imagine.
All right,
So I think that's a very big thing, and the behind operator is important, yeah, but it sort of gets overshadowed by the array notation for me.
Well, it gets overshadowed by me, and I thank you in the comments. People are telling me to up my audio, so I've turned up the gain, and hopefully this will make it easier to hear me now. Let me know if this fixes it a bit. So I have been, what do you call it, like a sideline watcher of the array notation. I've seen that you put out, calls for requests at points and stuff. I have never fully understood the value. You showed me a few things that were definitely cool, but I guess I program not at a large scale with APL. So sell me the curious, but not fully understanding. You said it's changed a ton of different stuff. What is it changing? What does it give you? And also, too, does this exist in other languages like BQN?
Yeah, so
it was kind of borrowed. Because I program in BQN, but I can't say, maybe I am silently enjoying this feature without realizing it.
Right. So yes, BQN sort of has it. It's a little bit different than BQN. It is ever so slightly, with one tiny detail different in Dyma APL as well. But it all comes of this work that I and others have been doing for the last decade. And that's where those ideas of the array notation came. That's why it went into Dyma APL. That's why something similar went into BQN as well. And maybe you don't think of it as a separate thing, and I don't really want it to be thought of as a separate thing than the core language. Right? We have been developing it as a separate feature, but as actually Camilla, you know who that is? You had her on as a guest as well, right? She pointed out when she was interning at Dyalog and was writing an initial implementation for it, that the spec wasn't complete. And the reason the spec wasn't complete was because it's not a separate thing. It's not a separate language. It is an extension of the existing language. So I wish that in the future, there will be no such thing as array notation. It's just part of the language. It's just part of how APL is. And maybe that's why it doesn't have as much prominence in, say, BQN, because it was put into BQN early on, and it doesn't have sort of an identity of its own. It's just part of the language. And it's the way that you can write the arrays. So I find it sort of remarkable that APL existed for over half a century. That's a long time in programming language terms, right? As the original array programming language, and did not have a notation for arrays. So in early on the APL, you could write numeric vectors and scalars. You could write character vectors, strings if you want, and character scalars. And there was one exception of a one-element vector that you couldn't write. And that's it. If you wanted to write a matrix, which you think that for all the capabilities that APL has in dealing with matrices, it's got a single glyph for matrix inverse. Right? And for Ken Iverson's love of matrices, even to the point of sometimes extending language, wanted to extend language with primitives that dealt more with matrices when actually other representations might have been more efficient or easier to work with. You couldn't even write a matrix, right? When somebody would ask, how do you write a matrix in APL? You can't. The only thing you could do is you could reshape a vector into a matrix. Or you could perform some other operation like an outer product and generate a matrix. But if I just want to write, I have my textbook and I want to write down this matrix, there just wasn't any way to do it.
Is there technically a way in BQN? I'm trying to think. Like, usually the way that I would write a matrix, if I'm not reshaping, is to do a list of lists and then I don't even know what the glyph is called, but the equivalent of like mix or unmix, where you're...
Yeah, that's what people were doing in APL for a long time. That they would do a mix on the... but yeah, I think you can write square brackets and then you write multiple vectors separated by commas or diamonds, and then that's a matrix. And that is exactly what we can do here. So I like the way it looks, especially now. So there's so many, as I say, knock-on effects of this parallel to this development of array notation, and somewhat in preparation for it, we extended the APL session to do multi-line input. So I can write a matrix like this, right? So I can literally use 3D programming. Not 3D, sorry, 2D programming. 3D would be nice, but this 2D programming. So this is a matrix, right? Which is pretty much the same way you write it in a math textbook, other than the square brackets, you would have them extend over the full height of the matrix. It would be awkward to type that. So this is a matrix. You see that here? And that means I can even write expressions like, let's just make a small one for now. So I can literally add this to another matrix, and I can indent that here further. And maybe we'll do something about that, some smart indentation in the future. We haven't done that yet, but right. So this two matrices being added together, and this preserves the idea that the language is linear, right? And there's just a new line coming up here, and we continue over here, and we continue over here. So we don't have to parse it in a 2D way, but the matrices are nice and rectangular. So a knock-on effect that this had was that, wait, now that we can represent array literals, not as expressions, then why not output to the session, the REPL, not like this image of a matrix that you cannot go any further with. Notice, by the way, a fairly new feature as well, these brackets that show input that belongs together. So you can sort of see, because now it's not just one line. Now it's multi-line input, multi-line output. So you have these brackets. But we now have on the Windows IDE over here, we have a button up here you can turn on array notation for output. So now if I go and I execute the same statement here, we actually get a matrix output as well. And then a further development from that was, wait, if the output is done in a way that is executable APL notation, well, then why shouldn't the output as well be input? So whereas before you'd have separate lines of output, sure, they're marked as belonging together, but they're not really, don't really form any group. I can go into this output and insert more numbers into my matrix, and then I can execute that. In fact, a further development of that is, wait, now that the REPL, the session, became more of an editor. We're not just editing a single line. Now it's like a full text editor with multiple lines of input. Then we should be allowed to do other operations you would do in the editor. So I can actually reformat my function, even though it's not a function. It's just this line of input. So he's reformatting it, which we can see if I write like something strange like this, then it will reformat those numbers into the normal forms, and then I can execute that again. So all of a sudden we have a whole different way of working with input and output. Instead of always having to save my intermediary results in a variable and then use that variable's name to continue processing it, I can literally take the output and manipulate that, and it becomes new input, and I can continue working with it while still preserving a visual form that is present to the human. Right? There are other programming languages that print out executable code as the result, but then often it's not very pleasant to look at. I don't think I know of any language that has a REPL that prints out two-dimensional results that are also directly possible to manipulate and continue computations on. So if I realize, oh no, wait, I need to take this matrix that was output here and I need to just increment it by one, I can just do that.
Yeah, I guess this is very cool. And I think you've shown me that was the coolest thing that I saw once, is when you were doing kind of like editing of a matrix on an atom-wise basis. And but I guess, yeah, there's a comment in the chat from we'll take the first 4 characters of the username and go by Hans, but that may or may not be their name. That says, this touches on a point that says that I'm always struggling with between APL as notation and APL as a language, which isn't exactly my thought, but I see this and it looks very cool. But the immediate thought is, does this affect like notation as a tool of thought? Like the reason I love APL so much, and the reason I love things like the behind operator, is that it gives you a notation for like solving problems algorithmically with primitives, and then composing, the solutions to those problems with operators. And this feature, I don't think I will ever be like this. This is a language feature, not like technically primitives and operators are language features as well. So that's the wrong choice of word. But this is like a UX improvement, or I guess it's more than that, right? Because you can technically do this in like source code, I assume.
Yeah.
So it's a different kind of like enhancement.
I think it helps a bit in like. I think what you mentioned actually in your last video, that you published, we should have a link to that, which is a language comparison of solving a problem in various languages, and you conclude that Jello or Jelly provides the best experience there because you have one glyph or word for every concept you want to deal with. So let's say I have some algorithm, and I need to have a matrix. That's a fairly common thing to have in the middle of an algorithm, that you need to multiply it by some matrix, do some manipulations. It could be skewing some points in space like that. Then I want to be able to directly express my matrix and not have to construct it, right? In my mind, I see my matrix, right? It's 1 in the top left corner, 2 in the top right corner, 3 in the bottom left corner, 4 in the bottom right corner. Then in my mind, previously, I would have to ravel that out, think of its actual shape, right? 2, 2, reshape, 1, 2, 3, 4. Right. Which is just a distraction. It has nothing to do with what I was doing. I knew what matrix I wanted. And now I have to go out and find an expression that will give the matrix that I want. And adding another row to that matrix is really hard, right? If we write 2, 2, reshape, now, of course, I could write iota 4 here, but just for the sake of argument, let's just say that these are some numbers. Now I want to add a middle row. So I have to go in and count and find, I want 2 zeros here, but that's not going to work, right? Because then I have to go and update the shape. But if I wrote it, and we can even write it inline. If I wrote 1, 2, 3, 4 like this, and I realize, I need to add another row in the middle of 2 zeros, well, that's really easy and easy to spot. So I think it does help when thinking about things, that I'm allowed to stay within the line of thinking that I have, and not go do other things, because the language does not provide me the capability to express the array that I'm thinking of.
So this is it's a fantastic response. And then the thought I was having in my head is, well, technically, if you have some like 3x3 matrix that you're calculating some operation on, how do you put that in some linear program? Like, are you literally like, center, horizontally center, is it horizontally? Vertically center justifying like your primitives, because you've got, 3 rows for your matrix. But then you showed this syntax. And then my thought is, you said BQN has this. What is BQN's equivalent? Because like I said, my matrix... I
believe this is valid BQN code.
Really?
Oh, no, not quite, because the vector's in here. So you would have to, either you have to enclose the inner vectors in that those angle brackets you have to use. That's not quite greater than, less than, something like this, or commas and things. Either that, or you have to use that curly underscore thing to write them together. But
yeah, so APLs is actually nicer in this sense because
I think it's cleaner.
Yeah. I've always thought
we can write it as well. There is a vector notation, just like BQNs. But so if I, instead of square brackets, we write round parentheses, now we get a vector of vectors. So they look very similar. But if we look at the shape here, you can see that it has shape 3. Right. So this is just a vector of 2-element vectors, and now we can have it ragged as well. So if we try to make this a matrix, meaning we can mix it, because you get the square brackets. So this corresponds to BQN's angle brackets.
Right.
But I wanted to use ASCII enclosures for this. And so the only symbol you need that's not ASCII is the diamond, but you can always put a new line instead of the diamond. So it's possible for ASCII tools to write APL arrays without needing any non-ASCII symbols. And there are very few exceptions to this. And usually those exceptions will not be relevant for those third-party tools that are not APL tools. You need an APL primitive to write enclosures that are like on their own. So if you want a further scalar that's enclosed, you have to use the enclose. And if you want an empty array, then you can write a zero replicate, because you need to specify what the prototype is. So we can see if I write 0 rows, 4 columns, reshape 0, you see it responds with a 1-row matrix, but compressed to have no rows, in order for it to specify what the prototype is. If I write characters, you can see it gets a 1-row character matrix compressed to 0 rows.
Right.
And this is generally an array that other languages than APL languages are not able to even conceptualize. Right? You cannot, in say JavaScript, have an array of arrays that on the outer dimension is 0 and the inner dimension is 4. It just can't happen. The opposite you can do. You can have a 4-row 0 array, right? This is an array of 4 empty. Or, I mean, it really would be split in JavaScript example. So this we can convert to JSON. Just write it like that.
Very interesting. And I mean, I had this other adjacent thought that is, I mean, I understand the motivation for stranding in BQN, but it is unfortunate in certain times. There was some advent of code problem where it had space separated. Was it space separated? And yeah, you wanted, like, it's nice to be able to execute space separated and comma separated numerics that then immediately.
I mean, it's a bit hacky, right? Yeah, it's a bit. I mean, yes, it's nice, and it's nice to often be able to take data. So if you find data out there, it will generally either be space separated or comma separated, which is awesome for APL, because spaces means you just get a strand, and commas means you get concatenation. Either way, it just works.
Right.
And, of course, it's a bit hacky and totally unsafe, right? It's like you're running an eval on data coming from the outside. You definitely don't want to do that in a production system. But there are other ways to do it. So even if we take something like that's space separated like this, even if there's like uneven spacing, we do have a function called VFI that gives us the validity vector and the value vector. So if we and it uses by default space separation. So if you put in something here that's invalid, then you see the binary vector here is telling us that the second element is invalid, and then it uses a fill value for that over here, which means you can compress out the invalid values. And then we can, if we want to use special separators, so of course if it was commas, this would not work. You know, it doesn't understand at all. It thinks that the commas are tokens, right? And they're not valid. But we can tell it that we want comma to be the separator, and then it does it correctly again. That's really the correct way of doing it, and safe way to do it. So yes, it's nice. I also do that sometimes. You just copy and paste things, and it generally works. But I don't think that's really that much of a value. The clean look, I think that is a value.
Yeah,
no
what I was going to say is this
no
extends
noise
to array notation now, where it looks a lot nicer in the array notation compared to the kind of the noisiness that exists in BQN.
So you can also see that for the output, we choose to not use array notation all the way, right? It would be valid to use this, right? This would be array notation to all the way to the bottom. but that's very noisy.
Right.
And that's why we choose to, like, if we can use a simple strand, then yeah, we'd use a simple strand. Then it's much nicer. So going back to the question of how you think about things, this whole thing led to yet another feature, which was that I can now open the editor in array notation mode. So notice it says down here, it's a bit small, it says new array notation. So this window here is a new APL execution context. And I can use the reformat button to, or shortcut I'll use, you'll see every time it flashes, it's because I pressed reformat, to execute and replace the value of this array foo that hasn't even really been established yet. So let's just start with 2 reshape iota 4. And now I'm going to press the reformat button. I can also do that up here. I think there's edit reformat here. It says I can press the key to do it. And then it got actually it evaluated iota 4 and created the array notation for it. Okay, now here's where my mind is really like expanded in the capabilities, because notice now I'm not taking an output in the session and manipulating that as a new input and then having that become an output, and it becomes this dialogue back and forth, input, output, input, output. Instead, I have a constant input, and my input becomes my output that I'm then immediately manipulating. So let's say I want to reverse the rows here. Instead of having buttons, and before version 20, we had something called the David Liebtag's array editor, and it had like a toolbar of buttons like transpose and reverse and things like that, and ravel, and they correspond very much to APL primitives, which is not a coincidence, because APL gives you the primitives to manipulate arrays. So an array editor would need all the tools on its toolbar to manipulate arrays that correspond to APL primitives. So now I don't have to have an interface for that. I can use my muscle memory interface. So I want to reverse this array. I literally just type the reverse primitive in the location that I want to reverse. And then I press reformat and it's reversed. Now, if I only want to reverse this row, that's where I put it. There's nothing new here to learn. It's just APL. And if I want to insert a new column, I don't have to use APL operations to insert a new column. I can just go in and type that. And that's it. Now it has a new column. And I can use text manipulation tools. So I'll use rectangular selection and delete a column. So my powers have expanded. I've often seen APL as a way to express myself, to get the computer to do what I wanted to do. And my, should we say, vocabulary for expression has expanded, because I can now use text manipulation tools to manipulate arrays. I can now use primitives to manipulate values without having to affect variables and other names that are visible where I am. I think that helps me think about the arrays and express to the computer what I want in a way that just didn't exist before.
So here's a question. Does this only come bundled with the dialogue editor? Does it come with RIDE?
So that people often ask, does something work in RIDE? And it's useful to understand that RIDE is not actually an IDE. We even changed its name lately. We changed it from capitals RIDE to just the word RIDE. Because really, technically, RIDE is not an IDE. RIDE is an HTML renderer. So the interpreter and the IDE are intimately connected. They're one thing in Dyalog, and indeed in most APLs, I believe.
Mm-hmm.
You cannot separate them. And as you can see that you can't separate them, because I opened a new editor window using a language feature. Quad AD is just a function, like any other function. I can apply it with operators. I can do whatever with it. And it opened a window in the IDE. So RIDE speaks a protocol with the interpreter, whether it's on a remote machine or the local machine. And RIDE provides the service of rendering using HTML an interface that you interpret as a human, you interpret it as an IDE. But really, it's just rendering of the interpreter's internal concept of what the IDE state looks like right now. When you open a window on the interpreter sends a message over a protocol to Riot saying, okay, draw me a new window. When the user in Riot closes a window, then Riot sends a message back to the interpreter, okay, the user closed this window. That's what's happening. So does this work in Riot? Yes, it works in Riot because it works in the interpreter. We barely had to change anything in Riot in order to make this work, because Riot doesn't exist as an IDE on its own. It's really just the front end. So we did add some buttons and things to Riot so that it makes it nicer to work with. Like there's the edit with array notation, so we can actually switch back and forth here. So you can see here that it says here edit with array notation. I can switch to the normal editor, which is not very useful for numbers, but it's useful for text. So if we replace this with some text, for example, so yeah, now I have to type the quotes, and I can switch back to text mode, which is the traditional mode of editing things. So we can write something else here and switch back again. Notice here that it padded with spaces because we're dealing with a matrix. But let's say normally I would work like this with normal text. But let's say I want to insert a special symbol, and I don't know I don't know how to type that symbol. Say like a non-breaking space or something like that. Let's say I want to the non-breaking space, and I know that it has the ASCII code 160. So I can switch to array notation. I can go in here and write the APL expression to get it, like that. And then we can switch back again. And now we have a non-breaking space over here. So Riot gained an edit and a button to be able to switch back and forth between these modes, but and it had to deal with some protocol issues with the output groups that are also input groups, so that it knows to send the right things back and forth. But that's really the extent of it. It does work in Riot. It does work in the TTY version. So if you're running Dyalog in a terminal without Riot, it works there too. Just have to know the keyboard shortcuts for things.
Max is asking in the chat, does this feature have a way of showing you the history of manipulations?
Yes. So in fact, if we go back here, I can use the shortcuts that I use in the session for going back in history. It works here as well. So I'm going to press the back shortcut now, and you can see everything changing all the way back to the beginning of the manipulation of the array. So if I want to later figure out, wait, I want to put together all this, the algorithm. How did I get here? Right? I got the right result, but I forgot how I did it. So we can just go back and forth. We can go forward in time as well and see everything happening again. So everything is there until there's no more history.
Very cool. And he also asked earlier, does array notation open the door to function arrays?
It does. We haven't allowed it yet. I think there are a lot of parts of the interpreter internally that need to be tweaked a bit in order to deal with function arrays. Technically speaking, we already have them, but things aren't really set up for that. But yeah, in principle, it could do that, and then it would maybe make a nice way to arrayify functions, to just wrap them. So we could imagine making plus into an array just like this, right? So this is how you write a one-element vector. We saw that before with the shape, and then. But there are a lot of interesting questions that comes out. And what exactly happens if you take the first element of this? Do we get a function back? Which is possible. We could return a function from any selection function, just like execute function today, or a traditional function, a user-defined function can return a function. But there are a lot of considerations to be done there. And then I think now we've even just looked at basic arrays, and we haven't even looked at high rank arrays, but of course that works very much the same. So we can see here that is just that every line, so to say, this a logical line, is a major cell. So this square bracket out here is an array of 2 major cells, and each one of them is itself a character matrix. We got this. But we also have notation for namespaces, which I think changes possibly even more. Because earlier you'd have to create your array notation, your namespace either piecemeal or with a script. So piecemeal means you would write my namespace here. You have this system function that creates a new namespace. It's now a new empty namespace, and then you can well, we could switch this off so we can see how it would be looking in the old days. And then you would start propagating it. Right, foo is 10, and that's the bar. Is hello, etc. Yeah. Now, that meant that it was sort of awkward to use namespaces in like just one-off things. And the deeper your structure is, you would end up with having to repeat your path all the time. There's no way to like build it as a tree. The array notation allows us to do this super easy. So we can actually see it. We just turn the array notation on, print ns. We can see the array notation, which is very similar to JSON for JSON objects, but again in a APL form. So we're using round parentheses. We don't need any separators here. If we wanted to write it inline, we can write it with diamonds. So I can write like that. That's a namespace. And I can immediately dot into it and ask for the value of foo. Right? Or we could dot into it, and because APL allows us to dot, we don't just have to use names after a dot into an object, but we can write an expression as well. Right? So we can write foo plus bar. And this changes everything. It might not look like it, but like how many times I've turned to John Daintree, which is my colleague that has implemented this, and said like, "Whoa, John, I just realized like, wow, the things we can do." And so I've also suggested using an operator to modify the behavior primitives instead of setting these semi-global states like quad.io, right, that you're used to. So he suggested you could write something like this. So this would be an operator, sort of similar to how we have variant today, and this would change quad.io just for this primitive right now, and then you could write your number afterwards. Of course, this clashes with stranding, so that's difficult. And also other issues. Some primitives, like dyadic iota, has more than one variable attached to it. There's both the index origin, but there's also the comparison tolerance. How close does a value have to be considered equal? If you do like a lookup with dyadic iota, or for that sake, equalities and things like that. So now we can actually write quad.io :0. This is a namespace, a new namespace that will just exist for a brief moment, where that is empty. But of course, it has all the primitives in it, because every namespace has all the primitives in it. But it has quad.io 0. So we can dot into it and just get the iota from it. So now we don't need to set. If we just want a one-off, set a different value. And quad.io here is not affected, of course.
If my memory serves correctly, and admittedly I haven't taken a look at TinyAPL in a while, but doesn't TinyAPL have that variant thing?
It does have something like that, yeah.
Yeah, because I do recall.
But this allows us to do it more generally, right? TinyAPL has it very ad hoc for everything you might want to do. It has to have a separate symbol for it,
right?
And it has a general syntax which is sort of similar to this, which uses like underscore square brackets, where you can. But that's very similar to the variant, where you just use name value pairs to say what things are to set. So, but this allows us for free, right? We don't need to do anything, and we can do this also for passing parameter namespaces. And that's a style of APL utility. It's not so much as these core mathematical algorithms, but APL utilities that do stuff, lots of side effects and so on. We've in the last few years we've settled on a standard syntax for them. Where you have like myutil, then it takes some arguments, the main arguments, and then optional parameters are given as a namespace left argument. And then this utility takes care to unpack that namespace. And it's really awkward to use this sort of syntax to build your options before you call it. You see this, and JavaScript uses this quite a lot as well, where you have some function that method that takes some arguments, and then it takes some options namespace like that. And this is similar, but of course, dyadic function like that. And now we can do that. So we can set our options here, right? So we can say, skip to, and then we have some arguments over here. Definitely has made it easier to deal with those kind of utilities. Another thing we can do is we can use named arguments, right? APL is an array language, and we're used to having to bunch together. If you want to give many arguments, so to say, to a function, you have to put them together in an array, and then you have to deconstruct that array inside the function and put things where you need them. And sometimes it can be hard to remember the ordering of things. So now we can write this. So this might look like a function call in another language because you've got the parentheses, but it's not. Right? This is a normal monetic function that takes its single argument and namespace. It has two members, A and B. And it doesn't matter what order I put A and B in, we'll get the exact same namespace back because namespaces are unordered. So we can now write functions that behave as if they have named arguments rather than positional arguments.
It's basically not superficial the right word? It's a way of getting named arguments, kind of.
Yeah, kind of. Yeah. And maybe we haven't done anything special to account for this, but I'm thinking that maybe in the future we will do some like automatic destructuring of these, and maybe automatic structuring of these. So you could like declare somehow inside your function that this function takes a namespace argument, and then instead of the function actually receiving a namespace argument, you get all the members of that argument already available to you inside the function. Right. And the same thing you could do with a result, where you can say, okay, this function delivers an object as its result, and instead of having to create the result as an object, you just say which members will the result object have, maybe even have a facility to say what the default values are, and then the function will create those variables, and at return time of the function, it will take all the names that you have said need to be in the result and just collect them and make a namespace and return that automatically. So you don't have to think about it. Those are definitely possibilities for the future.
This definitely does feel like a paradigm shift.
That allows me to think about things in a very different way.
Yeah.
Right? So and I believe in being allowed to implement things whichever way you think of it. And the language shouldn't restrict you as to how you're doing things. If you want to do things procedurally, sure, do it procedurally. You want to do it tacitly, you do it tacitly.
Yeah.
You do it functionally, you do it functionally.
And speaking of TinyAPL, Rubenberg, aka Madeline, creator of TinyAPL, popped up in the chat and then mentioned that there's different operators for different parameters. And then Max mentioned that this is useful for quad CT, which then the next thing that Madeline pointed out is that there's 4 primitives, index origin, four things that you can set via these. Index origin, fill, comparison tolerance, aka I assume that's what quad CT is, and backward, which is for flipping the order that reductions happen.
Yeah, that's what TinyAPL. So Dyalog has a few more. It doesn't have all of those. It doesn't have the ordering of reduction. We could maybe do that. There may be other things we could do. Dyalog has a bunch of other ones that you could do. So
is this? I mean, for some reason, the trench coat function idea popped into my head. This is not the same thing, correct? Right? The idea of a trench coat function being the best example is like P colon in J, which is a prime function.
Anything to do with primes.
It's like 12 different prime functions in one, and I admittedly never remember which is which. If I'm solving some kind of problem and I need something with primes, especially if it's on codegolf.com or whatever that website is, code.golf, You go and you go p colon, and then you try the first one, then you try 0, 1, 2, until you get the one you're looking for. This
Yeah,
kind of
circle
is
is the most well-known one in APL. It's
APL.
the only is in Dialog APL. It's the only primitive that is like trench codey, right? That takes a number to choose what you want to do. But no, I don't think this is that. Right? This is weird. This is something you could have always done, and I know a lot of people have done things like this, where they created a namespace called IO0, and then they've set IO0.quad.io to 0, and now whenever they needed a quad IO0 iota, they would use that. Right? But now you don't have to create this utility namespace, and also this namespace wouldn't be available everywhere. It would only be available where you created it. Now you don't have to do that. Now you can just write this, and this allows you to set multiple options at the same time. Right? If I want quad IO0 and I want quad CT,
Right.
0, right? Then I can combine them like that. So it's
me
sort of
think
similar to
this makes me think
variant.
of Jelly has two different primitives for iota 0 and iota 1. And when I was creating Jello, I was like, well, what am I going to call these? And so I'm pretty sure I called one iota and the other one iota 1 or iota 0, whichever one wasn't there. But like it has autocomplete, so whenever I need an iota, they both pop up, and so I know which one I need.
Yeah.
But
this says this says on the tin what it is, right? There's no doubt about what this means. As soon as you know that this is namespace notation, which is, I think, it's a very obvious syntax, then you can read this. It's no different than what you had before. There's nothing has changed in iota.
So it's like what do you call it? Like a customizable trench coat that is always open, so you can see how many lemmings are inside. Or like
you could say that. Is it a good system that you can change the behavior of primitives? No, I don't think so. I think it's better to have a more limited language that always does its thing, than having variables that definitely the way we have it with like globals that changes. I don't think it's a good thing. But we're all about backwards compatibility, right? You've got to work with what we have. And I think it's much better to selectively, like on the smallest possible scale, you change the default, and then do it in a way that is easily readable like this, that you can see what's happening.
Yeah, this is very the array notation rabbit hole / I guess the extension into namespaces goes much deeper than I would have imagined. And
I mean, if you want, I can show an example of how I would use it. It's an example I just thought up one day when I was presenting for someone.
Yeah, go ahead.
You might have seen this before. So imagine we want to make a counting function, right? That counts from one number to another number. So so let's say that we let's call it range. So so we can make range something like this, right? We can say we start with just iota omega. All good. But now we want to have maybe a starting point. So now already we have to have a left argument, let's say. So we say omega minus alpha, and then, right? So now we can, that gives us these. Now we need to have them offset. So we can write alpha plus that. So we're almost there. We just need to add one more alpha on the left. Okay, so now we have the 3 range 10, and we go from 3 to 10. Now I realize, oh, wait a minute. Actually, I want to be able to do a step size. I want to take every other number, 4, 6, 8, 10. What am I going to do? Where am I going to put this third parameter? And also, let's say we want the default to start at 0, so we can do that with this, right? Okay, that's good. But how am I going to have a default for the step size? And they're both numbers. I can't even use like disambiguation of the of type or something like that to know if I'm supplying a left argument that's a step size or not. So imagine instead that we make range take a namespace. So in order to access namespace, because we don't have this automatic destruction, we're just going to dot into the namespace argument, and then everything we do in there is going to be inside that namespace. So now we want, this is the to value, and this is the from value. Right? So now it's even easier to read. You know what's what. This is the from. Okay. Now we can write range from 4 to 10. Okay. Nice and readable. Okay. Now we can go in and do the step size. So if we want to do a step size, we want to take this range here and divide by the steps, the step size, and then we need to round it down. And then we need to do step size multiplied by this range. I think this is correct. So now if we do step 2, yeah, and now it doesn't matter which order. So I don't have to remember, like if we could make a function called range, right? That could be range 10 or range 410. And then where does the step size go? In the middle? At the end? Before? Now we don't have to remember that anymore. It doesn't matter which order we give it because it's a namespace. Of course, if I leave out the step size now, it's going to fail. Value error. So this is where this other version 20 feature comes in, which is the namespace manipulation stuff. So let's say I have a namespace namespace that has a value A, and I have another namespace that has A is 0 and B is 5. And I want to merge them together. So this is a new thing in version 20 that Quad_NS can merge namespaces. So we have to return that namespace here. So notice that the A value got overwritten by this namespace value over here, but the B value, which wasn't set by this namespace, it survived. So we're merging these two objects together to create a merged object. Actually, what this one did was it merged this one's values into this one. We could also create a new namespace, a third namespace, but it doesn't matter in this case. So this gives me a way to supply default values. You could think of A being a default value and B is a default value. So the user overrode the default value with a custom value. But B, which the user didn't care about, stayed with the default value. Okay, so instead of using this object, which was given by the user, so let me just show how we do it. If we want to create a third namespace, you can't really see the difference here, but this takes these two and merges them into a new namespace that this creates. So that's what we should do, because we don't want to change the user's argument. We want to just take the parameters from there. So on the left of the dot, we don't want to dot directly into what the user gave. We want to create a new namespace that is based on the user's namespace with some default value. We want the default value of from is 0 and the step size is 1. Okay. Now we can call our range function, and if we leave out the from value, then it starts at 0. And if we leave out the step, then it's step 1. And if we leave out both of them, then it's just starts counting from 0. Of course, if we leave out the to value, we still get a value error because the user didn't specify that. So that's a way to say, okay, it has to actually have a to. So now we could put in a guard inside the function that says, okay, if you get a value error, then we give a nice custom message to the user, hey, you have to supply at least 2. But this way of writing an APL program, it's still very much like functional, still very much APL syntax and everything. But the way for the user to supply an argument, the interface to the function is completely different. And you could technically do this before, but you'd have to jump through a lot of hoops for the user to supply his argument, and also for the function to unpack and create, deal with default values. That just wasn't a good way to do it before.
This makes me think that I guess I never realized maybe I had a aversion to namespaces, because most often when I'm doing stuff or seeing stuff, like namespaces come up when like Aaron, I don't know, maybe you're in the boat as well, but I feel like it's this category of things that I call like namespace hacking. But this clearly is like a very powerful language feature And almost like I'm having like a not existential crisis, but like maybe I've always had an aversion to anything with like a quad next to it because it's not a primitive, like it's not quote unquote
Yeah.
like the APL that Iverson created. And then I was thinking, I wonder if you replace quad NS with like a primitive, and then you showed me this all with a primitive, I would just be like, wow, I can't believe you squeezed so much juice out of this single primitive. And so, yeah, like when I said it's a paradigm shift, maybe I have to maybe, and also namespace. I guess I've always semantically mapped namespace to like the equivalent of modules in other languages, which is not,
Yeah.
it's not entirely correct, but it's also not entirely false in that it is a collection of, functions and variables, etc. That in a lot of other languages you would reach for something called a module. I mean, in C++ it is called a namespace.
You can also see it as an object if in other languages. It's sort of in between. And we have a so in best Perlis fashion, we want to keep the number of types down and maximize the number of functions that operate on those types. So Dialog APL has a single type, the namespace, that both works as a dictionary and, as you say, like a module. It works as a data structure. It works as a way to organize your source code, but it's still a single type. When I teach usage of namespaces, I tend to split the course up into two, using namespaces as a data structure, like here, and using namespaces as a way to organize your code, which is very different. And that's what you've seen more of, I think. Still, should it be primitives? I don't know. One could be tempted to like use plus or something like that instead of quad NS here, but really don't want to make the primitives dirty, right? In that it's not like plus, it's not commutative here. It doesn't do the same thing, and it has side effects, right? Because it actually changes the APL namespace or Dialog APL namespaces are by reference, not by value. So it actually changes the values themselves. It doesn't just return a new thing. And getting primitives into that whole domain makes me a bit yeah.
Yeah, I mean, this is
Unsure.
APL in general. I don't think of as at least Dialog APL as a language that overloads the behavior of primitives based on the type. Whereas, or I don't know, maybe you can disagree if you think that it happens often. But whereas K,
No, I don't think it ever happens. We only overload based on, well, the primitives don't overload based on type.
right, right.
They occasionally overload based on value, but that is, I think, less of an issue. So this means get a random value from iota 10. This is sort of a different primitive. This means get a random float between 0 and 1. But you can't get a random value from iota 0. There aren't any.
Right.
Therefore, there's no question that it has to be different. So in most APLs, question mark 0 is just not meaningful, just a domain error.
Right.
And it's technically an overload, but it's not a. I don't see it as a very problematic one.
Yeah.
You could also see it with iota, right? That iota 2.3 gives us a 2x3 array of vectors, but iota 10 gives us a 10 shaped array of scalars, not of vectors.
Right, right.
So really, if we could go back and change things, if we gave it a one element vector, it should give a different result. It should really give this, right? It should give it, because this is a different, not type, but like a different value. This is a vector value and this is a scalar value. And then the corresponding vector value should give a one-dimensional array of vectors. But for historical reasons, we can't go and change that.
Right.
In practice, it's rarely a problem, but it does happen.
I mean,
that kind of overloading exists, but yeah.
That's the what do you call it? Formally correct versus pragmatically useful conversation that comes up from time to time when chatting with Marshall about his design decisions in BQN. And every once in a while, there is something that is useful, like the overloading of iota to get a matrix or is it J? Anyways, but he's taken a very hard line of no, I'm doing the thing that's like unsurprising and formally correct just because it might be useful in some instances. I'm not going to sacrifice the potential confusion of a user in the future that is like, well, this isn't consistent.
Right. I think Dyma went the exact opposite way in Dyma APL, where he defined reduction to do what you wanted rather than what follows from its definition. So like if you reduce over like a vector of vectors, then you don't get an enclosed result. It discloses it automatically because that's always what you want.
Right.
But it's not really technically correct. Anyway, that's a whole different discussion. We can have that and another time. But no, primitives in I can't think of any primitive in APL that is overloaded based on types.
Yes.
You could see the hybrid, the slashes, sort of like that, like, but it's not really that either. Like whether they have a function on the left or they have an array on the left makes them change behavior completely, be something else. But it's more parsing thing than it's the same primitive, really.
Speaking of slash, the hybrid slashes, it's a great transition point, seeing as we're already, what is this, 45 minutes? No, an hour and 15 minutes in? Time flies.
Something like that, yeah.
It's a great way to spend the new year, folks, is just deep diving on new features in Dyalog APL. I will mention that Madeline, once again, creator of Tiny APL in the chat, mentions that they have an analogous feature in Tiny APL called dictionaries that use the set operations for combining these sorts of things. So maybe we'll have to have, I'm pretty sure I did a Tiny APL episode. So we might have to have him back on.
It's a bit, the set operations don't really work for this either because of how they are defined, again, pragmatically. Like you could say that the union of 3 and 4 shouldn't be defined because this is not a set, right? It's a scalar, not a vector. And therefore you could say, okay, you can make a union of 2 namespaces, but that doesn't work because the way it works in APL is that we just treat the scalars as 1-element vectors. We treat them as sets. And therefore this would be this does work. It already has a meaning, which is just these 2 namespaces after each other. Again, array notation to the rescue. And you can see this is a vector of namespaces. So we can't do that with those operations either, and I can't really think of any good primitives we might even want to overload. And there are a lot of options as well. Often the system functions have some options in what you want to happen. And we haven't spoken about, there are 2 companion functions, new ones to quad_ns, called quad_vget and quad_vset, which are setting and retrieving variable values under program control when the name of the variable itself is something you might not know. And they have, for example, an option on triggering triggers. You probably never even heard about this in Dyalog APL.
Triggering triggers? Definitely not.
Yeah. So you can set up sort of like a sentinel function that observes its namespace. It's the namespace it lives in, and it can either look for a specific set of names or on all names. And when variables change, or when the value of those names change, then the function gets called to take certain action. So I mean, I can create one just to show you quickly. So if you write a function trig, take an argument, and then we can write implement trigger x, and then we just write a message. Okay, so now this function, it just exists. It just sits there. Now I'm going to give a value to x. Yeah. And in fact, the argument here in the trigger function is a namespace that contains the name of the thing that was changed, and its old value and its new value. So you can take all kinds of actions when a variable is changed for whatever reason. For example, you could have an object that has sort of like a field where the user can change some values, but you want to normalize the value. So every time the user sets the value, then the code kicks in and it goes in and makes sure that the value is normalized. Like capitalized or whatever it might be, rounded to the closest something, right? So you can take those kind of actions, or maybe write it to disk, right? Whenever the user updates some setting somewhere in the REPL, because it's an open system that you're just playing around with functions in the REPL, but when the user changes a setting, then you want to write the new setting to disk, so you could do that as well. So, for example, these system functions that set set a value to a variable, it needs to take a decision. Should it trigger triggers, or should it skip the trigger callback? And there could be more options like this. We really don't want to start doing a whole bunch of options on primitives for to decide the exact behavior. It's sort of dirty stuff, belongs in system functions. I call it systemy things that are not data manipulation itself. It is bookkeeping. It is management of things around. And there have been mistakes made. I think that the variant primitive should not be a primitive, because again, it changes settings for system functions. It has no business being a primitive. In fact, there exists a system operator that's equivalent, quad opt. I prefer to use that. So I don't think it belongs as primitive. There are things like the ibeam and ibeam and execute. Maybe the format primitive. Those are nice for code golf, for doing quick things, especially the last two. But really, they're doing systemy stuff, right? There's an eval, and you might want some settings for that. There's a format. You have some settings for that, and don't really belong as primitives. But hey,
yeah, Max is saying that these triggers combined with a couple system quad XSI and quad LC, useful for debugging. I did not know what those do, but I was thinking the same thing. Like, this is very, what's the word? I can't think of the word, but it reminds me. I'm thinking of reminiscent, I think is the word I was thinking of.
Mm-hmm.
From Visual Studio, they had something called a data debug breakpoint, where you could set an address, and if that address corresponded to a variable that was in the same space, or at least didn't get popped off the stack, you could track, when it get changed, and sometimes that could save you hours debugging, the value.
If you have a loop that runs like tens of thousands of times, and then that something funky happens when it reaches like some value, then you could and you want to stop in that and debug that, it can be really awkward to that. So you could use a trigger to set up something like that. I think we should have one, hopefully in not too far future. We should have something in the IDE that's built up where you can like monitor a variable name and say, okay, whenever this variable changes, then check this formula, and if the formula evaluates to 1 or 0 or whatever, then stop, right? Or tell me about it, or something like that. Right? There are IDEs that do that. You can sort of build that yourself with this. It would be nice if it was built in, but meanwhile, yes, you can do that. I think that's true. I think this segues nicely into talking about behind. If we still have time to talk about behind.
I can go until 40 minutes from now. I'm not sure when your hard stop is.
Me too.
Before we fully transition, I did look up quickly when I brought up Jelly having iota, and it is iota 0. So you can't see this, but the YouTube viewer can. So if you type iota, it gives you iota 0. And I was wondering, what do the Jelly primitives correspond to? Is it something that you would be able to like rationally guess? And the answer is no. Iota, as you can see on the screen, corresponds to R, and iota 0 is L underdot. So absolutely, I mean, a little bit of symmetry in terms of like LR left, right, but the underdot being there completely throws it off.
I think R is probably a range. Yeah. And I don't know what L is. L maybe lower. What is it? Lowercase L?
It's both capital cases. Underdot. But anyway, so
I don't know. They usually are like mnemonic for something, but I don't think it's documented what they're mnemonic for.
Yeah. So I'm sure that there is a lot of thought put into, if you look at what the max and min, and there's a lot of times like I think half is H and double is like H exactly. Or underdot or something. There is some thoughtfulness put in, but unless if you're spending time daily driving jelly, that probably is not going to stick. Hence why I
I
need Jello. But
I don't know if
anyways,
anybody knows jelly like as an active vocabulary. I remember chatting with Dennis who um created jelly, and as he was working on jelly as well, he was also working on another language, M, that was supposed to be like a replacement for jelly, but never finished it really. Um, I asked him how he works in jelly. He said he also looks up the primitives,
oh, so there's
even
no
though he
hope for
created the
anyone.
language. No, it's got 250 primitives and like that. No. I think we're already pushing like the pain limit in Dialog. I really don't want to add a whole lot more primitives, even if something could be nice to have. I'm very like reluctant to add more primitives because it's it's nice to have everything available. It becomes like an evolve from a language. You have to look everything up or have long names. Remembering that many glyphs. The Japanese do it, I guess, but
Yeah. Sometimes I wonder, like, is it worth, not that I would ever do this, but like the thought crosses my mind. Like, I would love to have primitives for like unit testing and stuff, but like, are you really going to remember that primitive? And I was like, well, you could just use like the test tube emoji, which is, it's written on the tin what it does.
But how do you type that? With the emoji
Uh,
picker?
yeah, I mean, I have like a keyboard shortcut that brings up. I mean, once again, the user won't, or you won't see this, but the YouTube will. Oh, it's on the wrong screen. Can I move it? I wonder if I click here.
I think I can. Doesn't this? No, it doesn't share.
Yeah,
I
but
only share the
it's like a little
window.
emoji keyboard
Yeah,
autocomplete. But
yeah, but I mean, the economics of this not
yeah,
great.
it's
I
not
think
gonna look nice, right? Like
no.
it's an idea that like floats through your head, and then immediately you go, well, that's not gonna look good like an emoji. Like, because didn't someone create a programming language that is the
There are
combinate?
multiple of them. Yeah,
Yeah, there's a combinatory like SKI combinator logic, but it's all emojis, but they have a bunch of birds or something like for all the combinators.
yeah. There are multiple of these languages that use emoji, and it never turned out a really good idea.
Yeah,
Never mind. How do you handwrite that stuff? Sit
yeah.
there with your colored markers and it's and APL definitely does get handwritten at times,
I guess
for
that's
sure.
true.
Like on the blackboard, on a whiteboard. Every workshop that I run, so on, like, yeah, people write and take notes and during workshops and things. You don't want to do that.
Well,
So
when you mentioned the 3D array notation, I was thinking in my head, it's only a matter of time till we've all got some, workable Apple Vision Pro that, like, right now I'm in
yeah,
front of monitors, but in the future we're gonna have these virtual things, and your 2D representation of a 3D thing is gonna become an actual like floating 3D cube of values, which, I mean,
it's definitely
that's gonna be
doable. Think
cool.
about it. We're used to seeing 3D things. Like if you see my face right now, you perceive it as a 3D thing, even though you're
Hmm.
actually seeing a 2D image. And so it's a projection of 3D space to a 2D space. And even the normal APL output for a 3D array, if we get rid of the boxing here, if you write 2, 3, 4, right? So this is also a projection, right? We flattened out a 3D to 2D, and we can sort of see it that this is the top layer and this is the bottom layer over here, and they're just like been smeared out on top of each other. And in principle, it should be possible to, or I mean, it is mathematically possible to project any dimensional space to a lower dimensional space. And there would be no particular reason why you can't take a 4-dimensional space and project to a 3-dimensional space and then wear 3D goggles and travel through that. And I have actually been speaking with John Daintree about wanting to do this, where you have your little like 6 degrees of freedom controller with your hand, and you put on your VR goggles and you fly through your array, and they twist the knob and you like turn to see it from the other side. Just changes the projection. Can change sizes of things to see how far away they are. Right? Yeah, there are possibilities. Practically, is this something you want?
I've always
Maybe.
pictured like a Beat Saber like game where you've got some little lightsaber that you can draw the primitives. It's not that hard to do a rotate and an iota and a set union, and so then you've got some, I don't know, game where you've got expressions and you got to quickly reverse something or rotate something, and you'll be able to, like, it's the only language, array languages that are primitive based, that you could quickly kind of draw the primitives and then react in. Like, you can't write a Python program to, I mean, you technically could, but you'd have to be at a keyboard. But like, you could do a Beat Saber, like, like I'm Harry Potter waving a wand, drawing characters. But that future is not here yet, folks. Anyways, let's transition to Behind and spend the last 34 minutes talking about the best thing, in my opinion. I mean, it might actually be array notation now that I've seen how deep the rabbit hole goes, but that doesn't mean that Behind is not beautiful. And it fixes, people. I didn't really explain it in my short video where I was just, talking about how awesome it was, trying to get people excited. But it fixes. It's more than just a operator. It fixes things like and that's why I said it was a good transition, even though that was like 20 minutes ago now. The hybrid slashes, because half the time, a large degree it doesn't really work. And now with the Behind operator, in that instance, it basically fixes it. So I'll throw it over to you, though.
I'll start by doing the segue from this, where we go back to dealing with namespaces. So this is something I just discovered, you could say, recently. Sometimes I want to do something like execute an expression. Let's say that we have written some custom DSL for the user, right? So it's a domain-specific language. It has some primitives, whatever. We're going to simplify it very much. Let's say the user writes an expression in this language where they want to add foo and bar. Okay? So I want to evaluate this DSL, but foo and bar are not available normally. I have them. So the user's input comes from outside. I don't want the user's expression to have an effect on my code here that's running here. I'm going to simplify things a lot, but let's just say like that. This could have side effects. It could do whatever. I don't want it to affect my things here. So I want to run it in a new namespace, but I want that namespace to have foo and bar available from here that I've just set them up here. Now, the execute primitive, since you haven't been dealing much with namespace, so you might not know this, that it actually can take a left argument, which is a different namespace, name or reference, and they will execute that expression on the right inside that namespace. So if we create a new empty namespace, which is, by the way, now we have notation for a new empty namespace, inside an empty namespace here, then we get a value error because there's no bar, no foo. I can create a new namespace with quad ns. This has always been possible. Quad ns foo bar means create me a new namespace that copies in the values of foo and bar to variables called foo and bar. So copy in those members from here into that namespace. So if we turn on array notation, we can see that this gives us a new namespace that has foo and bar in it. Okay, so we can write a parenthesized expression over here and say, okay, create a new namespace that has foo and bar and use that as a left argument for execute. That's great. I think it's nice to be able to create new primitives, so to say, on the fly. So I want to change execute just a bit. Instead of taking a namespace as its left argument, I wanted to take a list of names that I want available in my expression as its left argument. So I want to be able to write like this, right? I want foo and bar available, and in that availability, in this namespace, let me execute this expression. Make sense? Okay, but there is no such primitive, and I can't create new primitives, except Behind very often allows me to do that. So if we look at what I actually wanted from before, I want to apply quad ns behind the left argument of execute, right? If the left argument is foo bar, I want to take the quad ns function and throw it behind that argument, right, on the left. So now I can do that. Oops, sorry. Quad ns. So you might think of function composition as something we do with algorithmic things, with pluses and minuses and reductions and things like that. Here are two very systemy things, an eval, and I create a new namespace based on this list of things that it should be populated with. And I just created a new primitive, if you want, function, whatever, I don't care. That takes a list of names on the left, creates an evaluation context, and execute the expression on the right.
I mean, now the real tricky thing is can you get rid of the plus expression and like on the right? So if you make it just a list of variable names, can we modify this expression so that your like space, your plus joining them? So basically create this foo plus bar expression.
Yeah, we could write function gets plus, right? And then we can copy in the function as well, and then we can write function in between, like this.
Or no, so what I meant was, say you just have your list of foo and bar, and then you want to have that as your right argument.
So like this, we just get their values out.
Yeah, but then put foo and bar as two separate strings.
Then you have to do execute each. Okay.
Well, so the thing that I'm thinking is if are we able to use the behind? Maybe not, because we might need the S combinator, which we don't have, to basically join foo and bar with the space with the plus. So just like recreate your string from these two variables, and then you don't need your expression. So basically, this would be like creating a generic function to add up the variables in a namespace if you just have the variable names.
You could, but this is not the right way to do it. That is exactly, we didn't even touch on that, but we need to stay with behind a little bit. But this is what vget is for, right? So if we have a namespace, let's create this namespace that we created up here, right? So, and then, oops, yeah, that's fine. Okay, we've got our namespace, and then I can do quad ns, quad vget, foo and bar, and I get those values out. Right, that's a better way to do it. And now we can insert our plus or whatever you want to do. Right?
I mean, vget very useful in this situation.
It is.
So the abomination
vget is awesome. Yeah, no need to go to that abomination. Yeah, vget and also vset have become a huge thing for me as well. Like but we don't have time to go into that. Like, for all this discussion we did about the namespaces, there's so much you can do with vget and vset.
We'll leave something to talk about on a raycast.
Yeah, I'll throw out some bait for that. Like, imagine if you can take a CSV file in and change that immediately into a namespace where every column is a variable. For example, right? Imagine if we can have a namespace that represents this CSV file, right? And we want to get out a specific column, so to say, right? So we use quad vget. So the user specifies the name of the column they want, and we use quad vget and just extracts that column from there. Vget can do much more. It can do default values. It can, whatever. It can give you lists of things. It's amazing what it can do. A tiny little taste of it. Let's say I make a mistake. I divide by 0. Okay. So there is a system namespace that gets populated, called DMX, the extended diagnostic message, and it's a namespace. It's got stuff in it now, so we can even see the source location of the Dyalog interpreter where this error happened. So we can see that this part of the interpreter is written in C++. File, we have the file name. We can line 356 of scalar mathematics, I think it is, something like that, and is where this error happened. Okay. So why did I do this? Not very important, but this is a namespace that's got a bunch of values in it, and I can write quad vget -2. This gives me name value pairs for this namespace. So I'm converting an object into name value pairs. So here we can see it's a huge array. We see category is a variable name, general is its value, DM is a variable name, and this vector of character vectors is its value. So we can manipulate namespaces very easily like this. So this allows us to do some really cool stuff that, again, we shouldn't spend too much time on. But let's just say that we have a namespace. It maybe comes in from some JSON, whatever, right? Where we have ABC is 10, and and def is 20, right? So namespace. Let's say I want to lowercase this object. What does that even mean? So what I mean here is I want to lowercase all the names in the object. Yeah, good luck doing this in your language of choice. But this is super easy because I can write quad ns vget 2. This gives me the name list and the values. So it's a 2-element vector, which means I can run a lowercase or casefold in this case on element number 1. This gives me the information I need to create a new namespace that I then feed to vset in a new namespace. And the result of this, which you can't see, you just created it, but we return it, is a new namespace that's the lowercase version of this namespace. Okay. So you can use this when people have like an options namespace or something, and you want to make it case insensitive, then you can just take the namespace and sort of say casefold the namespace, but casefolding all the members of the namespace, and then you work on that further. So this is vget and vset in action. So I think this is pretty cool.
Yeah, Madeline in the chat is saying an under moment, seeing the vset after vget.
Yeah, sort of. Sort of, not quite, but yeah, sort of.
Yeah.
Okay, so behind, and we saw a little bit with behind on this namespace, and I think that's something that we can do a lot in general. So let's say I want to create a text file. And I want to write that. So we have something called quad input. I'll give it a. Okay. This doesn't work. Why? Because quad input is a really powerful system function. It takes a vector left argument of which the first element is the content that needs to go into the file. Now, 99% of the time, I don't want to set all those powerful things, encoding and line breaks and whatever I want to set. I just want this to be the first element. So we do that by enclosing the left argument. Right? So how can I change quad input in a convenient manner so that it considers the entire left argument as the first element? I just need to wrap it, or I just need to do an enclose. So I can write like this. So again, you might see behind something you use in all kinds of fun compositions, but I use it for very like down to earth, bread and butter, side effecty stuff as well, and it's not bad for that.
Well, I mean, I remember Elias, cap creator, said one time that he made the choice of not putting 3 trains in. He does have forks, but they're syntax based, and he said in his experience, the before and after, or in our case behind and a top, at least half of it, they account for like 90% of the stuff that you would reach for a monadic fork for. And so you don't actually miss 3 trains as much as you would think if you have these primitives, which until
I think a very important thing there in cap is that it does sort of have forks. It has AGH forks. The ones we have array functions,
yeah,
right?
Yeah.
It has that because it has that extra catch there. Then a lot of forks are not necessary anymore, and that I think that's true. The tiny APL goes even further. It has these half train operators where you like when you want any train of the form tech like this, right? There are lots of these left tech GH right there, and right tech GH, and FG left tech. I think it has so these are all 2-function compositions, and I think it has maybe only for 2 of them, maybe for all of them, I don't remember. So those are also common forks. So the fork is like a generalization of all these specializations that you could do.
Wait, so I'm reading Madeline's comment. It says the variant of behind that gives both arguments to the left function is useful too.
Yeah, it's not a variant of behind really. That's another fork and another composition. There's so many compositions you could do, right? So you could have let's just comment this out. You could have something like this, a composition where you want x, f, y, g, some function. No, sorry, not g here. G, h, y. Right? This is sort of a lopsided fork. The way we would write it as a full fork would be not fgh, because that would feed the left argument to h as well. We'd have to do h atop
Yeah, I
right
was going
tag.
to say this is just a diagonal
Right?
fork with a tack composed
Yeah.
at the right.
So all these are all specializations, right? The fork, the full fork, FGH, dyadic, right? That's the most powerful one. And then you can use tags and atop tags to specialize it. And yes, you could add combinators for all these different things. You could. We're just gonna drown in primitives. How many primitives does tiny APL have? Right? It's not a tiny number.
Yeah. I mean, this is my next thought was that technically, if you had an array language that didn't overload, didn't have ambivalence, you
Yeah, then you could
could.
do some things, but not everything. Because think of this one. If this is monadic, say,
Yeah,
strictly
if you
monadic,
do it on X or
how would
Y
you
or
know if you
Y.
want? Yeah, exactly. So you still need to have some kind of specification of it. Either that or you need commutes everywhere in order to guide it to do the right thing. So I like forks. Uh,
I
I
like
I
forks. We should get a T-shirt that has
yeah.
the fork emoji, and I like forks.
Um, that and maybe it's a good middle ground. I mean, you could also do the whole the operator trains that they have in J. I think that's too far. Yes, there are things you can express elegantly with them, uh, but even the person who implemented them has to like really struggle to find use cases for some of them.
I
Um,
mean, we spent a whole Minnowbrook, Josh and I, trying to figure out, and Peter, trying to figure out one just for one of the verb or the
yeah,
what was it?
the CCC was,
Yeah,
isn't that the one
conjunction
we would like?
train, and we
Yeah,
couldn't figure
so
out.
the CCC is like is FC G C F. Well, they shouldn't be C. Like if all of these are combinators, or C1, C2, 3, 3, then it's like this. Right? That's the triple conjunction train in J. But like it's very rare to need this. I'm sure there are cases. Yeah. Okay, so since we don't have very much time, I highly recommend watching the video that I did on behind. It has lots of examples. And I thought I'll just show a couple of things that I find are really cool that are not in that video. I didn't show them that video either because I hadn't come up with it yet, or because it was a bit more complicated, and I didn't want to make it too complicated there. So there's some pragmatic things. Let's say we have some values, and then we want to put a header on it, right? So numbers, right? This is a classic mistake people make because they think of this as a string as a scalar. So we want a variant of catenate that encloses its left argument. So we can do that like that, right? Another one, it already exists where if we have some numbers here and we want to catenate and enclose the right argument, we already have that with a beside. So this is very useful. And of course, we could have primitives, right? We could have a primitive that encloses the left argument and concatenates, right? But that's you have an explosion of primitives. It's too much. So being able to compose them like this, create your new primitives, I think is really nice. Something that I hadn't really thought about much because we don't use this word, but you've mentioned it in some talks you did, was filter. Filter is sort of a bad name, you've said, because it doesn't say do we filter in or filter out.
Yeah, I've had this conversation with like 10 different people on 20 different occasions, and I agree. It is, Weewa's name of keep is a better name. That being said, it's kind of like a term of art. Like if you go to Google Translate, almost every single language, the semantics of filter is filter in. So like, I agree that it is ambiguous, but it's kind of similar to like scan. I mean,
Yeah.
scan makes you think you're scanning in documents or you're reading something in, and it has nothing to do with that. And it is confusing when you go to a language like Java that has literally like a scanner fundamental object that's in every program. But it's kind of like scan is less of a term of art than filter is, in my opinion. Some people
Okay,
in
so
different
APL doesn't
spaces.
have an issue here, right? Because it's called replicate. There's no question that it replicates. Like we get one H, one E, zero L's, and so on. So that's also a good name for it. J calls it copy. That's the same. It's a simpler word for the same thing. But if you want to call it filter, then it wouldn't have been nice if you had a filter out. Right? So filter out is just this.
Ooh, that's very nice. That's very nice. In
And you can
fact,
literally see it's a nut filter, right? This is the yes filter and a nut filter.
yeah, I guess BQN has there is
It would be the same.
the without BQN create incantation because they don't have without.
This is not without.
I know. But like BQN doesn't have without. So whenever you want the equivalent of without, they have
Then
like
you
a
have
little 4-character that I believe basically has this equivalent, but with the other meaning of the not. Yeah, this is really nice. Without is one of the things I miss in BQN.
Yeah, it's very useful.
Yeah.
And the set functions you don't have, right? Something I use a lot is I use set functions for filtering. So let's say that we have some text, right? And I want to extract just the uppercase characters. So you might go, okay, I need to see which ones are uppercase characters, and then you need to select those. No, we can just do an intersection with the uppercase alphabet. That's it. We filtered.
Oh, that is very nice. I don't think that would have come to me. This is why
And
I
if you
need I
want,
need to up my array foo,
if and this I think this comes up in a lot of like challenges where you have some like code and then some value, and then we want to extract the number that's in there, right? Super easy. Done.
Oh yeah. And technically if you wanted to get the individual numbers, you could just that's a little bit trickier actually because what if they're
Oh, no,
missing?
you can do that. Here, look. Just do like this. Just add spaces as well.
Well, so I was going to say what if you have just the letter like A between 5 and 666?
Yeah, then you can't do it. Then you have to split. But I mean, we can still do it in a nice way. So let's say if we put an A here and we want to get the numbers out, then we can use behind, right? So then we want to do membership of quad D gives us this.
Oh yeah.
And then we want to use that for petition.
Yeah.
Yeah, this one.
Very nice.
So that's another behind right there. Yeah, using it with partition, using it with replicate is really nice. Using it with index and pick is really nice. What was just another one that just came just when I was preparing actually for this recording, it just struck me that if we had, let's say we have a multidimensional array that's nested. So let's say we do 2, 3, 4 reshape quad A, that gives us this, and then we split it. That gives us a matrix of vectors, right?
Mm-hmm.
In the traditional view of it, the box view, you might be more used to seeing it looks like this. Now, if we if you want to get, say, row 1, column 3 of that, it gives us a nested result. But let's say I want to pick that. So normally when we've got a vector and we want to pick something out, we can use pick like this. But multidimensional pick requires an enclosure, because if we write 2, 3 here, so if this was multidimensional, this actually means element 2 and then element 3 of that. So that gives us the F. So how do we do multidimensional picking? We do that by enclosing. So 2, 3, pick here. But that's awkward because I don't want, so you see this extracted, it's not enclosed anymore. I don't want to have to enclose this. I just want to be able to have a primitive that allows me to get the element 2, 3 picked out, which we can write like this. Which even looks like some Cyclops emoji thing. Right? And this does the same thing. So you can think of this as like multidimensional pick. It's very nice. I think so. It's really nice.
Anything that uses behind is nice. Is it the new best primitive on the block?
I don't know if the best primitive, but
I was gonna say it's the best new primitive. Definitely. Is it
the I can, yeah. There are a lot of things that you can do in this kind of pattern with where you have some selection function, that a comparison function like that. And you can go crazy with this. You can make things that some people would consider abominations. But I think they're very nice. There's an old APL Quest problem called elimination sort. Some people know it as Stalin sort. So the idea is that how would Stalin sort this this vector? Well, he wouldn't actually reorder them. He would just go and shoot anyone or send them to the gulag, anyone that's out of order. So we want to get rid of the 1 and this 1 and the 2 and the 6, right? Then the vector is sorted. You know what I mean?
Mm-hmm.
Right. So this was a problem like that, and we can do this really nicely. So if we do it, so we want a continuously either equal or rising values. So if you do a maximum scan, then we can see that anything that doesn't match the current maximum should be eliminated. Right? So 1 needs to be eliminated because of that. Right? So which means we can use with behind. So this is the elimination vector. And then we can use another behind to actually eliminate them. So this is the elimination sort using 2 behinds.
Look at that.
I think that's about
not enough. You need 2.
No, you need more. I'll do another APL Quest one before we stop, and that's APL Quest 2018 4. We can put a link to that eventually. So it is, speaking of New Year, so it sort of simplifies a little bit, but it tries to give like the Chinese animal for the current year, and for that you need a giant array of the names, or those animal names, and I don't like having to write like monkey, rooster, and so on. Mm-hmm. So instead, I want to pack them together. And we can do that. So I'll just go copy it over here. So just pack together like this. You can still parse them as a human because you can see every one of them begins with a capital letter.
Right.
And so we can split them on capital letter by saying membership of quad A, which is the uppercase alphabet. Right, that gives us this. And then we use that behind partition. Right? And then we get them split up like that. So that's nice.
That's very nice.
And then and now we want to select which one it is. So it's just a cycle, right? So we can do the 4th year, then we can do a rotate, and then we can do a first to get it out based on the current year.
Right.
Now, why do I not just pick it out? Because this allows me to automatically get like cyclical indexing. Right? Whenever I get to beyond the end, it just starts over. Right, so that's nice to do a rotate. And it's fast. It doesn't actually do the rotate; it just computes immediately where we go. But there's one problem, and that is that there's no year 0. Right? Because before year 1, in the proleptic Gregorian calendar, was year -1. Right? There is no year 0. Mm-hmm. So that means that we need to adjust the values. So if we have year -2, year -1, year 1, 2, they need to be adjusted. So this is conceptually -1, this is conceptually 0, and then these are 1 and 2.
Right.
So how can we do that? Well, we want to add something, right? So we want to say, are they greater than 0? Sorry, are they less than 0? Like, I'm intentionally going to put it on this way. You'll see in a moment why. Okay. And then we want that value added to the year value, right? So then now we have adjusted for the year 0 by making -2 into -1 and -1 into 0. 1 and 2 stay the same. Yeah, we don't actually need this anymore.
Very
okay,
nice.
so now we can put all of this together, right? So we're going to create a little defen. It's not going to be entirely tacit, but that's fine. 2026, say, we take this whole constant thing that we're going to compute in, because it's nice to have it inside the function, like that. And then we're going to do the rotate. And I don't want parentheses, so I want my omega over here. So I want the left argument to the rotate to be pre-processed with this function that does the year adjustment. So I'll copy that in here and put it behind, right? So now it's rotate, where before we do the rotation, we apply the adjustment function to the left argument. Then we rotate the value that was computed over here. And then finally, after the rotation, we just need to do the first to get the first value out. Okay, so that gives us the Chinese animal for this this year. And
is that accurate? 2026.
I don't know. It doesn't matter. It is according to the problem as stated, which is not entirely correct, because I think the Chinese New Year is not quite the same as the Gregorian New Year.
Right.
But it doesn't matter. The idea is that I'm using 3 behinds. That's the important thing.
3 behinds, folks. You can never have enough behinds. All right, so we've got 2 minutes left. Am I allowed to ask a final question that hopefully doesn't take 120 seconds to answer? And we can defer it to an array cast if we can't answer now. So I was trying to remember the list of things that are like my top things I want either changed or added to Dyalog APL. And I was trying to think in the back of my head, I don't know if I actually have all of them, but in no particular order: sort, compress fixed, more combinators. I don't know if nothing counts as more combinators because it's not really a combinator. But if you're a big fan of no parens, I mean, technically there's less parens if you got nothing. And then under. And so compress, I count as fixed because we've got behind. More combinators, behind corresponds to 3, sigma, delta, and we didn't talk about D2, but maybe we'll have you back.
Split compose, yeah, that's nice.
The split compose, reverse with compose to get D2. And that leaves sort, nothing, and under. So the last question is, are these on the roadmap? Because I think there's a future where, like, BQN's been up here, and like you're growing closer, to the things that we're missing in Connor's mind's eye or whatever. Anyways, you're head of language design, so you might not be able to answer. But
no, that should make me as qualified as anybody can be to answer this, right? Roadmap, not quite. I prefer taking it really slow. We've got time. There's no particular rush.
Knock on wood.
I liked reading Marshall's 5 years with BQN, whatever it was, and looking back. And I was planning on pushing for the depth operator. I even had like the whole keyboarding and glyph and everything and model all done, and it was already basically agreed on internally and externally, well received. But then Marshall said, like, looking back, that probably was a waste. Like, you don't need it much, and when you need it, it's these very special cases of it. So I prefer taking it slow and not making mistakes. The under operator, I think, is something we definitely want to do, but there's a lot of work to do there because we have to get our inverse story right. And because we already have some inverses and we want to preserve backwards compatibility, we might want, as Morten Kronberg wrote in a blog post, you might want to have 2 different under operators, or maybe only do partial, because there's the computational and mathematical ones. And I think it's better to be clear about what you want rather than having the system guess what you want, because they can give contradictory results. But so there's some design work to be done there, some thinking to be done. Take that slow. Sorting primitives. I'm pretty sure I want that too. There is like the duality where that I see between like preparatory functions and do the action functions, and then the combination of those. So here's an example of that. We've got the unique mask function. That's a preparatory function. It gives you information in order to find the unique. Combine that with compress, and you've got unique. And for sorting, it would be grade is a preparatory function. It finds the grade. And actually, we're missing a primitive there that's high on my list, which is select primitive. But we can do that now with behind as well. That takes the indices and selects those elements, and that gives you the sort. So if you want to, and there are more examples of this, if you want to preserve this duality and have all the tools available, when you want the preparatory function on its own, you have that. But when you want the already combined preparatory with the selection function, then you have that as well. For that, we need the sort. And I think it's something that would make people happy. It's not difficult really anymore, but 1 character instead of 5 characters, and remembering how to do it exactly the right way. There's an interesting question on the glyphs. I think I've settled on wanting to be less than equal to and greater than equal to for sorting, rather than my original thought, which went into BQN of and or. Because these are comparison functions. I prefer the monadic and dyadic forms of functions to be in the same domain. Right? The dyadic forms of these is number theory and logic. The domain of these is comparison, which sorting very much is that. And these are sort of biased, right? Because you might think of the direction. There's only one direction, from left to right, because that's how you're right. But a lot of people, their main direction is from right to left, right? Or everybody who writes Arabic or Hebrew, their main direction is from right to left. And saying that this is ascending is not really correct. What it does is lower values on the left and higher values on the right. But why is that ascending? Why is that not descending if you look at it from the right? And if you do a reduction over something that you have sorted ascending, then you actually start with the highest value, because the reductions go from the right. So I'd rather have a symbol that's asymmetric. This tells you that the lower side is on the left and the higher side is on the right. And this one is sorting the other way. And also because if you have a sort, so this is a sorted vector, then it is universally true for a simple numeric vector. It is true that the pairwise less than equal to reduction is all true. Okay? So it'd be nice to have this symbol represent a manipulation of this array such that this identity holds true, and the converse the other way. That's why it shouldn't be less than, it should be less than equal to, because sorting can have identical values next to each other.
Yeah, I'm totally on board with that. Honestly, the way I remember BQN, although it's kind of just muscle memory because you use it so often now, but was that like the hat looks like it's pointing up, and
yes, that is true, but that is biased.
Yeah, it is biased. It is biased because we are left to right, or at least I read left to right in English. But there are many languages that do it the other way, right? So
yeah, on a daily basis, I read both ways.
Right.
And APL is to a certain degree right to left oriented as well, right? So I think that's a better choice.
Yeah, and I think if this had showed up in BQN, like I have like a semantic attachment to these symbols now, but really like this is probably the better choice because there is a lot more going on in terms of like when you think of a sorted sequence, this is the like baked into the C++ sort is a default binary operation, which corresponds to, less than
equal to. Yeah, exactly. So that's the benefit of moving slow.
Yeah.
I came up with this idea of using and or for sorting up and down. it went into BQN. I think it went into some other hobbyist APLs as well. And then upon further reflection, I realized that, wait, maybe that's not ideal. And because we haven't just jumped into doing it, we can choose the better design. And maybe monetic and the NOR should be something else. I have my ideas for that as well. Because as you say, they point up and down. So it'd be nice to map them to something that actually goes up and down, rather than something that actually goes left to right, right to left.
Right.
So I have my ideas for that. And the last thing you said was nothing. It has always bothered me that it's not exactly the same thing as cap in J, but it's effectively the same as cap in J. And always bothered me that it's a weird, in J, it's a weird function that doesn't really behave like a normal function. It's not in BQN. It's officially a special syntax. I don't like special syntax.
But you also don't like parens, so
I also don't like parens. So I doubt that that's going to come. It changes the parsing of things. There's a lot of questions come up, like what happens if you try to make an array that has it? What happens if you try to return it and whatever not? It needs another glyph and so on. I mean, yes, it could be a dot or something, but I think I'd rather say at that point, maybe it doesn't save that much, right? So you need it when you need a lot of monetic functions after each other, at which point you can get rid of all the extra noise of the nothings and just write an explicit function, a little defen. It's one more darn thing to learn, right? Because it doesn't abide by normal syntax. It's just you have to know what it does.
Admittedly, I think it's at the bottom. Like I said, it was no particular order. If I had to rank them, probably nothing would be the lowest. Probably sort is at the top, and then under's in the middle. And that's because really the only time you want nothing is when you're trying to, I don't want to say code golf, but you're tacit programming, and then you hit some situation where you have to put, the shortest thing to do is to put 2 parens in, because that's shorter than the braces and an omega. And
no, very often you can write nothing as a jot, right? So let's say that I want to write say reverse comma the negation of the floor, right? So, or maybe this is not a good use of the negation of the minimum. Okay, so now we write some numbers, right? So the problem here is I can't put on the top here. It doesn't work because of this reduction. So I would have to put parentheses over here to get this result, right? Mm-hmm. Whereas in BQN you can put that nothing over here and you're all good. But in many cases, because we have the beside operator, you just put a jot there. Not all cases, but very often you can. So the need for it in APL is much less.
Right.
And it even looks like pretty good for nothing. Right?
Yeah, just find a way to use jot and then call it nothing, and then you're good to go.
Yeah, that's what it does here. In the case where it doesn't work is when this itself is a compound function.
Right.
So if this function was, say, I don't know what we should say, a transpose or something, and it's some transpose, so combined with a reverse, so it's like a 90-degree rotation, and we have a matrix or something like that, that wouldn't work. Right. Or if this was some other reduction thing that we wanted to do, then it wouldn't work. But those cases are pretty rare. And often there will be something that wants a left argument anyway. So let's say it's like a 2-wise reduction or something like that. Then you put in the 2, and then you're good anyway. So in those rare cases where you cannot write it with the jot, I think you're either better off writing with parentheses or giving the subfunction a name, or just go with an inline defen, right? And yeah, it's not as pure, and maybe it's not invertible. Like this is unlikely to be invertible anyway. Right? But pragmatically, does this really weigh up the real cost of another keyboard shortcut you have to know, right? Or another item on the language bar, another syntactic construct that does not follow the rules of other things in the language. It's yet another category. What is it, right? And what happens if you try to assign it and so on? I don't think so. I don't think it's worth it.
Well, you heard it here. You heard it here first, folks. Sort in the potential future, also under maybe more than one. Nothing, not so much, but that's gonna be 4 out of 5. There might be something that I'm forgetting, but we can talk about that on a future
I mean,
episode.
I have lots of lots and lots and lots of ideas. I'm more looking into extending primitives to be more powerful. So versatile, so that your options are broader without having to learn a lot new
Right.
different things. So that might come another few primitives, like you say. I have an idea for the analytic and an OR to be promote and demote, which is like adding and leading axes and collapsing axes together. And those are nice because the promote is like goes up in rank and demote goes down in rank. So it's nice to have those symbols to point up and down, and they sort of look like the shoulder markings on soldiers as well. So like you give a promotion, they go up in military rank, they go up in rank. So you have more of those go up in rank, and then the downwards arrow going down in rank, demotion. But again, these are using monetic forms of primitives that are already purely dyadic. Very few new glyphs, I think you'd expect to see. Maybe select. That is likely. So the sane indexing type thing. Under will take time. So if we're getting those things that you're saying, it will most likely be in the order you're saying. Like sorting is a no-brainer if we want to do it.
Well, Dyalog 21, we don't know when it's going to be coming. Maybe 22, 23.
It's unlikely to be Dyalog 21. I think we'll do a fairly short release cycle for 21 where we like fix up things, and there will be some big things, I think, so that it won't be a 20.1. I hope, unless something's like broken in 20. And then we're gunning for a big version 22, maybe in a couple of years. Might have more exciting.
We'll be here waiting for Sort and Dyalog 22. You heard the promise, folks. You heard the promise. All right, I've kept you 10 minutes over. What time is it now?
Fine.
13 minutes over. But or technically, it's 43 minutes over. If you really, we readjusted mid recording. But thank you so much. This has been a blast. I learned a ton. For the viewers of this or listeners of this, stay tuned, not just to Tacit Talk, but also Arraycast will be back at some point, hopefully early 2026, early meeting January, but Adam and I have to meet to chat about that. Happy New Year to you, Adam. Happy New Year to the viewers and listeners. Depending on where your year starts, you may defer it by a month or two, or maybe it's a little bit early. But yeah, it was awesome to chat, and we'll do this again sometime soon.
Yeah, thank you for inviting me.
All right.